Hello, and a very warm welcome today to everyone who has tuned in. I'm Nick Alamaris, Managing Director of 3D Scanners, the only master distributor of PolyWorks software in the UK and Ireland. And we are happy to have you join us today on our journey into discovering the latest innovations in PolyWorks 2022. We've put together an exciting, informative, inspiring show which we hope you will all enjoy. We are hosting our event from our offices located here in Barford, a little oasis not far from the hustle and bustle of the M40. But PolyWorks is a global brand with offices located all around the world, from Africa to India and back to the Innovametrics headquarters in Quebec. Our range of customers showcased that the global metrology market is diverse and growing, yet one thing remains the same across all industries: the transformation towards digitalisation. Moving our 3D measurement process towards a digital platform is essential for maximising productivity, while safeguarding high standards, and it's this today where our journey will begin. So first up, a discussion on how we can assist you in deploying a gradual approach for the digital transformation of your 3D measurement processes. Next, we will follow up with 3 user-focused workshops, highlighting new features included in PolyWorks 2022, namely, inspecting multiple pieces without CAD, optimizing CNC CMM measurement sequences for the Renishaw PH20 probe head, and improving measurement operator performance by deploying mixed reality technology. Here at 3D Scanners, we are passionate about supporting our customers every step of the way. We want to help you to achieve the full potential of your data through supporting teams to become more connected, collaborative, and productive with the PolyWorks software. In doing so, we want you to optimize your use of the PolyWorks to shape your processes with better solutions, more knowledge and skills to eliminate busy work, to champion better, more efficient working. The need to release products quickly without compromising their quality is crucial, but sometimes this is easier said than done. We all know too well from recent events that staff shortages have become the norm. Things change, timescales shorten, and demand increases. With this in mind, we've curated a catalogue of specialised services designed to deliver on all of these elements, including hands-on training courses and consultancy services that will help you reclaim your productive time with simple strategies to cut out busy work. We all have different reasons for attending today. Some of you are in the early stages of your PolyWorks journey and still getting to grips with the software, whilst others, more mature PolyWorks users, are looking for ways to hone in on your current skills in the hope of fine-tuning processes to unleash hidden efficiencies. The same goes for our technical support line. We now have queries ranging from how can I install my license keys, all the way through to requests for information on creating an advanced workflow. But whatever your reason may be for calling our support team will always offer a helping hand, and that's not all they can do. Being under a valid annual support contract unlocks a world of benefits that many customers may not realise. So, to give you a brief overview, on top of unlimited calls to our support line and access to the latest PolyWorks updates, like the ones we'll be discussing later today, we also offer 24/7 access to the Innovametrics PolyWorks Technical Support Zone, an annual on-site visit, think of it as consultancy, free weekly drop-in sessions at our offices here in Barford, and remote support sessions. Also, there is priority access to downloads, events, and other exclusive PolyWorks information. So enough of the formalities. Please feel free to contribute to the event today by simply using the chat at the right-hand side of your screen. Let us know if you have any burning questions, insightful comments, or just want to say hello. We'll keep an eye on everything and get back to you on any points. We can also arrange a call after the event should you need us to follow up on anything. Additionally, please get involved beyond this morning's discussion on social media and let us know any comments you have using the hashtag PWCLUK. I'm also pleased to tell you that today we'll be making a generous donation to Mighton Hospice, a charity focused on supporting people living with terminal illness and their families from the point of diagnosis all the way through to the end of life. So, without further ado, join us as we discuss how the latest innovations in PolyWorks will empower you and your company in building a smarter, faster, and easier solution to make your 3D measurement data more valuable than ever before. Let's take the next step together as we explore how best to deploy a gradual transition towards achieving the digitalisation of your 3D measurement processes. Thank you.
Thanks, Nick. Good morning, everyone. Thanks for joining me today. I'm here to discuss with you how best to deploy a gradual transition towards archiving the digitalization of your 3D measurement processes. As Nick mentioned previously, this transition is key for maximizing productivity without compromising on quality or high standards. Before we dive into this discussion, let us first recap from last year's events.
We demonstrated digital 3D measurement processes that optimized the fabrication of a steering knuckle. In Phase 1, we measured the part and used PolyWorks DataLoop to give direct access to the resulting 3D measurement data to everybody in need of manufacturing feedback. In Phase 2, we defined dimensional requirements within native CAD software by using the PolyWorks PMI Plus Loop model-based definition solution and shared this MBD with downstream applications. We also showed how to import the latest CAD model revision stored in a product lifecycle management system directly into PolyWorks. Finally, we put all the components of the PolyWorks ecosystem to use and demonstrated an optimized digital process for managing part design changes.
Last year, we demonstrated that the digital 3D measurement processes were within reach for all our customers. This year, we'll roll up our sleeves and show you how it is done. We want to show you how a digital transformation project based on PolyWorks goes on in the field, practically one step at a time. We'll talk about the installation, configuration, and the customization of our digital enterprise infrastructure to allow customers to maximize their benefits. We will show the benefits of the PolyWorks digital ecosystem existing through modules that can be deployed gradually, whatever pace you feel more comfortable with. This approach is important as by splitting a large project into smaller ones, enterprises have more control over their implementation calendar and can avoid disrupting their own operations. A gradual deployment also allows the team members to master their new digital tools and give feedback to the implementation team to quickly bring adjustments. By carrying out small, well-prepared projects and exploiting their employees' feedback, customers will obtain efficiency gains at every step of their digital transformation. So this morning, with some help from our trusted friends from across the pond at Animetric, we will demonstrate a typical 4-step implementation of the PolyWorks digital ecosystem as it occurs on our customer sites. First up, Benoit, who manages the development of the Animetric IT solutions, will explain how you can quickly interconnect the producers and the consumers of 3D measurement data by deploying a data management system and a web and mobile server. Next, the global expert in enterprise solution deployment, Jean-Sébastien, will reveal the importance of implementing a metadata management strategy to maximize your data management system's performance. After that, we'll head over to Elizabeth, Animetric's web interface manager, who will show how production teams can automatically monitor certain piece dimensions, notify the right people when a dimension is out of control or out of tolerance, and quickly assemble an investigation team when a dimension failure is detected. And finally, Simon, who oversees MBD and PLM integration solutions, will take the floor to explain how you can digitally interconnect your 3D measurement and your product definition ecosystems to eliminate silos and facilitate collaboration. The first step towards implementing the PolyWorks digital ecosystem is setting up an enterprise-wide data management system for 3D measurement data. Why is such a thing necessary? Because for the first fundamental issue that needs to be resolved is access to data. Without access to data, digital processes are simply not possible. Managing data is a core of all digital enterprise solutions. Here, Benoit Toujon will explain more about this, and don't worry, he simplified this so all your non-IT folk can follow and understand exactly what he's saying.
PolyWorks DataLoop, our data management system, is straightforward to deploy. I'm going to show you how a metrology expert with basic computer skills can deploy DataLoop in 3 steps. 1. Provision the required servers. 2. Install and configure DataLoop. And 3. Deploy DataLoop to the end users. First, you will have to ask the person in charge of IT to provision 2 servers, either on-premise or in the cloud. The data server requires Microsoft SQL Server, a database, file stream enabled to store files, and a service account to connect DataLoop services. All your 3D metrology data will be stored on this data server, making backups much easier. The application server that will host DataLoop services requires Microsoft IIS, a server name, and an SSL encryption certificate. If needed, server access can be customized to meet your company's security needs. So far, these are all common IT requests, and nothing is specific to DataLoop. Similar to a workstation that comes with the OS pre-installed, the server infrastructure comes with the basic elements already configured. Then, as a metrology expert, you can install and configure the DataLoop components. The collaborative suite license server is installed by running a simple installer, and registration is done with an ID received from Enough-Metric. The DataLoop components are also installed by running simple installers. Next, you need to enter the database and service account information as provided by your IT service. No need to install anything on the SQL server itself. Now that DataLoop is running, the next step is to add users or collaborate with your IT service to connect using your network users. Once everything is configured, it is time to deploy to your users. Each authorized user can connect to DataLoop to the PolyWorks metrology suite, the DataLoop web interface, or a mobile phone. The only connection parameter is the DataLoop Core API URL, a simple and unique path to access DataLoop services. Once connected, your users are ready to upload PolyWorks projects and start collaborating. Once a project is uploaded, it is instantly available in the web and mobile interfaces. Note that download and upload operations only transfer what has changed, saving considerable time and traffic on the network. Moreover, DataLoop offers flexible security policies to control what the different users can see and modify in a project. Those security policies can be customized to your company's needs. For example, the addition of templates can be restricted to specific users. In conclusion, DataLoop is a modern data management solution, compliant with IT requirements, and easily configurable by metrology experts.
Usually it will take under a week for DataLoop to become fully functional. This involves installing and implementing a basic configuration. Once connected, users' working life will become much easier. From day one, all PolyWorks users will stop manipulating files and folders, and when they're ready to share the data, they just need to upload it. And users who need to open a project no longer need to browse for files, They just enter keywords into a search engine to find what they're looking for, as you would in a Google when using a web browser. For colleagues that need to consume 3D measurement data and have no PolyWorks expertise, it's like jumping into a whole new universe. They can access 3D measurement data and results from any platform, from anywhere, through a web interface or a mobile phone. They can exchange inspection projects by sending hyperlinks by emails or chat, and even possible to launch technical discussions and tag colleagues within projects, for example, to investigate an actual manufacturing issue. In our next step, we're going to define and implement a metadata management strategy. To understand the concept of metadata, just think about digital music. A digital audio file that plays a song does not come alone. It also contains the song title, the name of the author, the song's duration, a reference to the album, for example, and so on. This extra information that accompanies data is called metadata, and without metadata, it would be a nightmare to consume digital music, right? In a 3D metrology context, metadata consists of important attributes describing the part design, piece fabrication, and 3D measurement processes. Ensuring meaningful and usable metadata is critical to maximizing the benefits produced by a data management system. For further details on metadata management strategies, here's Jean-Sébastien Blais.
Metadata designates the set of attributes or information that can be attached to 3D measurement data and follows it. In metrology, it makes sense to have metadata that describes the design, the manufacturing, and the measurement story for each inspected piece. Such important information can be entered as project and piece properties in PolyWorks Inspector. Project properties derived from the design context include the part name, its number, the material it's made of, and are generally entered just once. Whereas the fabrication and inspection contexts will provide piece properties, or a pedigree unique to each piece. A raw material lot number, a machine ID, a serial number, the measurement device, the inspector's name. Since your enterprise is unique, you can define as many custom properties as you need. But which metadata is really relevant to you? Well, it's hard to answer this question by yourself. Instead, think about forming a metadata committee to determine that list. To make sure everyone's interest in consulting the metrology database are met, one representative of every department should be part of that committee. Manufacturing engineers will want to look at the piece rejection rate against material type, whereas buyers negotiating sourcing contracts may prefer to look at the rate against supplier companies. As you can see, metadata is the keystone in organizing information into logical groups so that data becomes facts. With your metadata identified, the committee should also establish the list of possible values for each metadata. This will ensure everyone uses the same expression to fill in the properties. Together, the list and the possible values are what we call the metadata management strategy. Fortunately, PolyWorks includes all the tools you need to efficiently enforce the exact metadata management strategy your committee agrees upon. First, to ensure uniformity, you can preset possible values both for standard properties and the custom properties you will create. Users will appreciate the convenience of selecting values from a list rather than typing required information. Second, you can decide which properties will be visible upon creating a new piece and make them required values. This helps the PolyWorks user focus solely on relevant properties and ensure the metadata is collected. After giving this a try, you will rapidly realize the same properties are often being reused across your different inspection projects. Therefore, you will be pleased to discover that you can upload and link the properties you always use to DataLoop. This makes it extremely easy and efficient to reuse them. Clearly, PolyWorks contains all the required tools to help you enforce a robust metadata management strategy. But remember, this all starts by identifying the key information to tie into your 3D metrology data. This is why we recommend implementing your strategy as early as possible within the PolyWorks DataLoop adoption process. You will soon discover that metadata plays a critical role in the resolution of manufacturing issues.
Essentially, metadata describes how a measured piece was designed, fabricated, and measured. Most customers already store important information about their processes within their inspection projects. This represents an excellent starting point for making sure their metadata remains meaningful and usable. We would recommend setting up a task force where stakeholders using 3D measurement data will decide on key information they want to store as metadata. What's more, cleaning metadata is very important for several reasons. First, it allows users to find inspection projects more quickly by using filtering. If you know one or two pieces of information about the project, for example, the operator's name or the date, or a production line number, you can considerably reduce the number of potential candidates in a search. Often you will find the project on the first try. Then, metadata is essential to carry out root cause analysis. For example, if you want to compare the part quality between two suppliers, you must be able to compare the dimensional statistics of one supplier with those of the other supplier. How are you going to perform this comparison if you don't know the supplier that's produced the measured data? You would be blocked. Metadata is critical to identifying and resolving manufacturing issues. The remaining steps in implementing the PolyWorks digital ecosystem are actually optional. Customers can choose to adopt these according to their needs and priorities. Here, I will hand over to Elizabeth Burson, the product manager at PolyWorks USA, who will discuss the PolyWorks enterprise solution in a context of production applications.
The digital transformation of your production department's 3D measurement processes starts with the PolyWorks digital ecosystem. PolyWorks DataLoop provides real-time access to all inspection data, and it automates many tedious, time-consuming human monitoring tasks, assuring that the right information quickly gets to the right people so that production isn't slowed or stopped. Here are the deployment steps to achieve those goals and benefit from DataLoop's strengths. First, create DataLoop user roles and permissions that correspond to the individual responsibilities of your team members. For example, create a role that allows editing measurement templates and a role with read-only access to inspection projects. Then assign user roles to your colleagues according to their tasks. Next, direct all PolyWorks installations to upload all the 3D measurement data captured by the PolyWorks Universal Platform to the centralized data management system. For measurement systems operated by third-party software, install macros provided by Innovametric to automatically create PolyWorks inspection projects from their 3D measurement data. Once users are assigned their roles and data is being collected, configure the DataLoop web interface to monitor inspection results and detect emerging trends. Provide a summary of critical piece controls with widgets like histograms, bar charts, and SPC charts to equip managers with an up-to-date global overview and actionable information. Set up well-organized inspection project catalogs for your measurement stations, sorted by date or filtered for a device. Build individualized dashboards with widgets that monitor the inspections performed there. Here, it's helpful to configure SPC monitoring rules and alerts that will notify the operator when measurements begin to drift. Likewise, create a dashboard to cycle through incoming inspection results on a big screen TV, providing a real-time reference for all team members on the manufacturing floor. Measurement trends that violate the SPC rules will display clearly in red, making it easy for operators to spot the issues that require immediate investigation. Finally, define notifications and alerts to automatically track critical inspection criteria in the DataLoop database. This greatly reduces all the repetitive manual monitoring you and your colleagues have been doing. For example, monitor the SPC performance of inspected critical hole positions, specify a list of recipients from the DataLoop users, and when the positions start trending out of tolerance, they'll be automatically notified. Or observe the percentage of controls within specification tolerance, or supplier inspection upload frequency, and deliver a notification when alert criteria are met. The PolyWorks deployment is now complete. Dashboards and alerts detect and highlight manufacturing problems and immediately notify those who should be informed. And here's where our built-in digital communication tools ensure that this measurement information is immediately actionable. DataLoop empowers the interconnection of users, manufacturing data, and problem solving by integrating modern communication tools within the interface. If you've been notified about a manufacturing problem via email, no problem. You'll also receive a hyperlink that directs you to the rich 3D measurement data context, so you can review the actual measurement data and make faster decisions. What if the problem is more complex and requires a task force to resolve it? Simply comment in the discussion thread directly within the inspection project, keeping the discussion linked to the data it addresses. Collaborate with colleagues by tagging them, and they receive a hyperlink to access the project data in real time. With streamlined access to 3D measurement data of manufactured pieces, automated monitoring, and by deeply integrating digital communication tools that accelerate the resolution of manufacturing problems, PolyWorks has created a new category of quality control solutions. PolyWorks brings 3D measurement data to the heart of your manufacturing processes.
Currently, there are several products in the market that can manage dimensional controls of production pieces and trigger alerts on detecting a dimensional failure. What sets PolyWorks apart is that it also manages the inspection project data and offers modern communication tools. So when a failing piece is detected, users are a single click away from reviewing a piece's dimensional data in PolyWorks, and a single click away from inviting colleagues from other departments to join in the investigation efforts. Instead of trying to analyze the production issue using only charts and histograms, customers can also work directly in 3D within inspection projects. Moreover, if a point cloud scanning device was used to measure the production pieces, customers can measure additional dimensions on these digital twins to deepen their analysis. In today's hyper-competitive environment, this capability of PolyWorks to react to production failures in real time can save enterprises hundreds of thousands of pounds. Our solution is fast and responsive in line with the needs of production departments. After all, they won't slow down operations just for us. With automated solutions, customers can now directly start measuring a new piece after launching the DataLoop upload operation. This improvement allows you to measure and inspect at maximum speed. Intermetric also are preparing PolyWorks to handle at least 1 million pieces within a single inspection project, and are working on archiving and backup technologies to control the use of disk space over time. In summary, they are creating the technology to manage the digital twins of the output of the entire production lines. The final digital transformation step will focus on improving the life of the whole community, the community of designers and manufacturing engineers that use product lifecycle management systems and CAD modeling software as their primary tools. So now let's listen to Simon Heroux, product manager at Intermetric, who will explain how PolyWorks can interconnect the 3D measurements and product definition digital ecosystems.
With its universal platform and data management capabilities, PolyWorks offers a formidable digital ecosystem to create and manage 3D measurement data. After having deployed our data management solution, you should digitalize and optimize the data flows between all the departments involved in the 3D measurement processes. With this objective in mind, we propose to digitally interconnect the PolyWorks 3D measurement ecosystem to your product definition ecosystem in two distinct phases. Where should we start? With your product lifecycle management system, also known as PLM systems. PLM systems are solutions that manage the entire lifecycle of a product by integrating data, processes, systems, and people, and providing a product information infrastructure. With a PolyWorks DataLoop PLM connector installed, you can ensure digital data exchanges between your PLM system and PolyWorks. PolyWorks users will search for CAD models within the PLM system and import them directly, and PLM users will directly access 3D measurement data and results in a single click, as our PLM connectors inject hyperlinks into the PLM items of the single parts and assemblies. A pretty good beginning, isn't it? With the deployment of PLM connectors, you can say goodbye to manually exporting and sharing data on network drives and browsing for files. You ensure that CAD data and 3D measurement data move effortlessly between all the teams. What's coming next? We recommend augmenting your corporate CAD software with the metrology-driven model-based definition solution, or MBD, to allow the creation of complete parametric 3D control plans within the CAD environment and increase the level of process automation. By enriching your CAD platform with MBD capabilities, you'll ensure digital traceability by associating measurable and traceable 3D measurement objects to CAD geometry and assigning unique IDs to each dimensional requirement. Digital traceability enables 3D metrology software to digest the MBD and its revision automatically. You'll also validate the measurability of dimensional requirements before embedding them in the 3D control plan, allowing 3D measurement operators to start measuring directly after imported the MBD. Finally, you'll create all dimensional requirements within your CAD platform, including the ones that were traditionally created within 3D metrology software. At last, users of CAD and 3D metrology software can share the same 3D control plan. Sounds exciting, but how do we get there? Firstly, users of your corporate CAD software need to learn the native PMI tools offered by the CAD platform using training material from your CAD software provider. With this new skill set, your CAD team will be able to define dimensions and GD&T attached to the CAD geometry and create multiple views to regroup this PMI in a logical manner suitable for reviewing and reporting purposes. Then, it's time to deploy the PolyWorks PMI Plus Loop MBD solution. PMI Plus Loop installs an add-in that injects a toolbar in your CAD software to provide access to MBD functionalities for 3D metrology that complements the native CAD PMI tools. To ensure a smooth adoption of PMI Plus Loop, we recommend the deployment in 2 steps. Your CAD user should first leverage the native CAD capabilities by creating native PMI using standard CAD tools, adding this PMI to the 3D control plan and creating measurable and traceable objects automatically, and assigning unique numbers to dimensional requirements for reporting and troubleshooting purposes. Then, they can start creating more complete control plans. For example, by creating new objects type, such as surface points, activating new dimensional controls that complement native PMI, such as airfoil dimensions, and using CAD coordinate systems to control the context of certain characteristics. We've talked a lot about a CAD team, but what about the 3D measurement team? Well, as PolyWorks Inspector automatically creates its 3D control plan upon importing the MBD data created by the CAD team, they have nothing to learn and can get to work sooner. We've just seen how the PolyWorks digital technologies bring together the design, manufacturing, and 3D measurement teams. In this new world, 3D measurement data is consumed instantaneously by anyone who needs it. Modern digital technologies eliminate silos and facilitate collaboration between all the teams. And dimensional requirements are created only once within the CAD authoring tool and reused for all activities in the product lifecycle.
As you can see, the benefits of unifying the 3D measurement and product definition ecosystems are overwhelming, and I have two further points to add here. Firstly, the universal access to 3D measurement data is the key to fueling the creativity of the engineering and manufacturing teams. 3D measurement data is already used to optimize manufacturing processes, perform virtual assemblies, simulate a piece behavior under various conditions, and improve the manufacturability of future designs. It's up to each organization to exploit this goldmine of information to its fullest. Secondly, the injection of hyperlinks within the PLM systems holds the secret promise of digital traceability. It becomes possible to digitize PLM-based enterprise processes such as design changes and part approvals, while referring to the complete 3D dimensional data that could be reanalyzed at a later point. PolyWorks integrates the digital twins of measured pieces within the PLM. Today, we are focused on the key steps of PolyWorks digital ecosystem deployment. Although there are further steps we could add, I think this sums up nicely the implementation overview. In the end, each customer is unique and must define their own transformation roadmaps by defining the steps that would optimize the performance of operations. To sum up, we have shown you the important steps of a digital transformation project for your 3D measurement processes. By deploying a data management system to offer everyone easy access to 3D measurement data and install a web and mobile server to access data on any platform from anywhere. Structure the metadata to optimize search performance and enable root cause analysis. Integrate PolyWorks into production environments to offer real-time access to 3D measurement data when an issue is detected, and modern communication tools to reach out to colleagues instantaneously. And lastly, to interconnect PolyWorks to the product definition ecosystem to implement MBD for 3D metrology and to bring 3D measurement data at the heart of an enterprise. Our digital transformation approach is unique. It's gradual to minimize business risk. You're completely in control of your own roadmap. Let's create success in a digital world together through making your data more valuable than ever before. We look forward to guiding you along your digital transformation journey. And now it's time to hone your PolyWorks skills with insights from our product experts. Let's explore PolyWorks 2022 and the latest features it has to offer with Luke and Ben.
Hello everyone, and welcome to our first workshop of the day, which will be about inspecting multiple pieces without CAD data more efficiently using measurement guides. Although more and more of our customers are moving towards a fully digital process using a model-based approach, a survey that was conducted back in 2019 found that more than 50% of our users still need to inspect parts without using a CAD model. Now, there are a few reasons for this. First of all, in some cases, the customer will only provide a 2D print, but no CAD model for the inspection. Another reason is that when in the early stages of product engineering, a CAD model exists but rarely matches the parts that need to be inspected, due to both the designer and the toolmaker being in an iterative process. Now finally, sometimes our users simply need to quickly set up a short multi-piece inspection with a few simple dimensions, maybe specified in an email or a chat message. In these cases, there are simply no time to wait for the CAD model, as the dimensional results need to be done as soon as possible. So you can see why inspection without CAD is still relevant and can even speed things up in some scenarios. For these reasons, Innometric have decided to streamline the process in PolyWorks Inspector 2022 by developing a new technology called measurement guides that enable the user to reuse the measurements from their first piece for guidance and extraction in their subsequent pieces. So, in this workshop, you will see how to create a template to inspect multiple pieces without using a CAD model. We will manually be measuring a first piece using probing and scanning, and then use our new technology to store this information and create an easy-to-use multi-piece inspection template with access to operator guidance, reporting, and SPC tools, unleashing the full power of PolyWorks Inspector. After this, we will see how easy it is to incorporate a CAD model into an already configured project, to expand your measurement capabilities and see how measurement guides can even complement your CAD-based inspections. The familiar inspection workflow with a CAD model uses nominal features that are extracted from the CAD model surfaces and curves. Then we use these surfaces and features to align our part to the CAD coordinate system. Now this process offers a repeatable alignment and guidance across multiple piece inspections. Until now, multi-piece inspection without a CAD model required a workaround to enable guidance for automatic feature extraction. Essentially, you had to reverse engineer the CAD process. PolyWorks 2022 introduces a new straightforward way to perform your multi-piece inspections without using a CAD model. So let's begin.
The heart of the solution is a mechanism that carries the geometry of the manually fitted or probed features to the next piece. If we know where a feature is relative to alignment geometry on the first piece, we can look for that feature in the same relative location on future pieces. This function is performed by a new tool called a measurement guide. It is a sort of invisible feature primitive that sits behind manually measured features and retains the geometry of the initial measurement, whether probed or extracted, and brings that information to subsequent piece inspections. Let's look at this new workflow as it follows the familiar hybrid inspection on this motorcycle part. We have a set of them that have each worn a little differently, and engineering would like to compare them. This memo lets us know what geometry we should use for the alignment. In this case, we want to use this plane and the two dowel pin holes for a plane center point axis alignment. There's also a brief note indicating the other features that need to be measured, both in the part cavity and the bolt patterns. Normally, we would start by measuring our alignment features, so let's do that here. Just like if we had a CAD model, we can use an alignment to bring our data to a coordinate system. This is essentially what we do with an alignment to CAD. If we were aligning to CAD, we would move the data using surfaces and features to corresponding nominal surfaces and features. In this case, we're bringing the features we would measure directly to the coordinate system. No CAD, no problem. The destination on the tertiary features asks us for a point. We don't know what the coordinates are where the circle is supposed to be, but we can choose which direction we want to clock it to by entering a positive number next to the axis it will lock to. Now the part is aligned and clocked correctly to in the x-axis. we'll continue to measure the rest of it. The whole pattern will be measured with the hard probe easily, due to the fact that the constraining plane has already been measured. The fastest way to thoroughly capture all the features in the cavity would be to scan it. This is one advantage of having a hybrid hardware solution. Surface-based features, like the planes and the cylinders in the part cavity, can be quickly fit using the Extract from Polygonal Model tool. You might notice that this tool moved in PolyWorks 2022. It is now with your other Extract Multiple Type tools in the Create Features menu. As usual, PolyWorks will initialize the curvature of the scan the first time you start picking features, after which picking will be near instantaneous. The shape of the selected area will dictate what type of feature is fitted to the data. Flat areas create planes, while curved areas create cylinders, cones, and spheres, all with Pick on Polygonal Model as the creation method in the feature properties. We can add nominal information to features and tolerance them in geometry controls. For groups of features, like the hole pattern that was probed earlier, or the cylinders which have different diameters but the same tolerance, select the relevant features and set all their nominals or tolerances in the geometry controls at the same time. In addition to features, other controls like cross sections and calipers can be added to the project to control the local width of the cavities. All sorts of calipers can be used on scan geometry, with or without CAD. As usual, the final step is to build the report, which has been completed. With the part inspected, we're ready to measure a new piece. Before we start inspecting it, remember that we manually created features, either by probing, extracting from polygonal model, or maybe another method on the current piece. Usually, if we were doing a multi-piece inspection with CAD, we would extract any features fit from the mesh. We want PolyWorks to do that the next time, so let's extract them now. Right-clicking and extracting measured changes the measurement method in the feature properties. When we change the measurement method to extract, our measurement guides take over and becomes the extraction source for the feature. It is normally invisible, but we can expose it by right-clicking on the feature and selecting View, Measurement Guides, Restore. Let's see how these measurement guides provide probing and feature scanning guidance and automate extraction in the next piece as we measure it. Now that we've launched our new piece, the measurement guides are visible for all features, giving the operator an overview of the part's shape so that they can start measuring the correct features confidently, even without CAD surfaces. When we're measuring the CAD model, PolyWorks automatically updates the alignment between the device and the part as soon as the alignment features are measured. The same happens here, and guidance walks our operator Matthew through probing the rest of the circles. After probing, PolyWorks prompts the user to begin scanning. And feature scanning guidance highlights features that have not yet been scanned in orange, and ensures that the operator captures enough data in the measurement guide locations for reliable feature extraction. When scanning is completed, the features extract based on their measurement guides, like we saw earlier in the feature properties, and the project will update as normal in PolyWorks. Let's double check our updated report. The operator can continue inspecting as many pieces as needed using the same process. As you can see, the measurement guides turn our CAD-less multi-piece inspection into a process with all the guidance and ease of a project that does have CAD.
So here we saw how easy it is to create an inspection template without a CAD model on PolyWorks Inspector. By using this piece template, we have the benefit of having guidance when scanning and probing on subsequent pieces. The measurement guide also allows us to use our powerful extraction methods to obtain results in an automated and repeatable fashion. With this template, we have the benefit of having guidance when measuring subsequent pieces, both for scanning and probing. And the powerful extraction methods on PolyWorks allow us to obtain results in an automated and repeatable fashion. This workflow proved incredibly useful in an array of situations, such as the CAD model not being available, the CAD model arriving late, or the CAD just simply does not match the part or the drawing, such as missing features or geometric discrepancies. These situations can also cause a series of issues, such as misleading information after the inspection is completed, time wasted looking for the correct version, and the impossibility of trying to measure features that simply aren't on the CAD model and don't match up. This is why in the next video we will see how to tackle those situations by incorporating the correct CAD model when it eventually shows up, so that you can use your extraction CAD-based tools such as color maps, surface features, and many, many more. You'll also see how you can use the new measurement guides to complement the CAD-based inspections when needed by measuring features that might be missing.
Matthew has already scanned several of these throttle bodies without CAD, establishing nominal features and an alignment based on the engineering drawing. We can now add the CAD model, update the project with the new nominal information, and use a template to push these changes to the pieces that have already been measured. The CAD model can be dragged and dropped directly into the project. Its coordinate system matches the coordinate system on the drawing that was used for the alignment before we had the CAD model, so the reference surfaces overlap the scan and the alignment checks out. When the CAD model imports in the correct location, nominal feature components can be extracted directly from the CAD object. Right-click on the feature and extract its nominal automatically using the second item in the right-click menu. PolyWorks will find the CAD geometry that matches the measured features and define it as the nominal component for the feature. Of course, extracting the nominal primitives from the CAD fills in the missing nominal information in the geometry controls, as is the case for these circles. Tools like surface profiles and reference object color maps are only available when you have nominal surfaces. We can add a surface color map to this project and adjust its limits by hovering the cursor over the scale bar and scrolling the mouse wheel until the full range of the scale matches the area we're interested in. Last step is to create a template and use it to update all the other pieces in the project. Since we added the CAD and color map in the first piece of the project, let's create a piece template from this piece and link it to all the other pieces in the project. Propagation ensures that our previously inspected pieces use the CAD model along with the new nominal information, as well as features and controls, or even color maps and reports we have added. The SPC charts now show nominal position information for the controls of these circles. There is another scenario in which pairing the new measurement guide tool with propagation can be very useful. In the event that there is a feature on the part that is not on the CAD, how can we include it in our multi-piece inspections? This throttle body has an insert where there is a hole on the CAD model. Let's use a measurement guide to include this feature in our multi-piece inspection. The cylinder is fit to the scan using the Pick on Polygonal Model tool. This takes us back to when we didn't have CAD. I'll extract the feature to tell PolyWorks how I want the feature to be measured on the future pieces, and the measurement guides become the extraction source for the cylinder. Of course, since I added the new feature to the template, I can propagate my changes to the other pieces in the project. The measurement guides will be propagated to the other pieces, so once again our SPC charts indicate that the feature has been painlessly added to every piece in the project. Our hybrid project has the agility to adapt when CAD data becomes available, and the flexibility to fully integrate all of the measurements you need.
So, in summary, if a user started inspecting without a CAD model, all the work that they did can be reused and even enhanced if the CAD model eventually becomes available. We can now add the reference model in post-inspection for some more advanced measurement tools and use the measurement guide technology to measure features that were missing on the CAD model. Finally, we can use the power of propagation to apply these changes to all previously measured parts for the coherent set of results for SPC with minimal effort. So thank you everyone for watching the first workshop of the day. I'm pleased to have shown you that inspection without CAD now follows the PolyWorks universal workflow in subsequent pieces. And now, setting up multi-piece inspections are more powerful and easier than ever, thanks to this new measurement guide technology. If you have any questions regarding any of the subjects I've covered, please feel free to put them in our live chat and our experts will get back to you. I'm now going to hand you over to Ben for our second workshop of the day.
Hello everyone, and welcome to this workshop where we will see how to create optimized CNC CMM measurement sequences for the Renishaw PH20 ProPed. I'm happy to be here today to present to you this new addition to PolyWorks' CNC CMM solution. Being relative newcomers to the CNC CMM market, and thanks to our vast experience in 3D metrology, we've been able to create a next generation user-friendly solution, as you will see here today. There is no text-based programming. The PolyWorks sequence is visual and flexible. PolyWorks' assisted sequencing technology helps you order the objects to measure and select which tool orientations to use so that you can easily get the most efficient measurement path. And the collision detection engine makes sure it is collision-free. In short, the PolyWorks CNC CMM solution is efficient and easy to use. You do not have to be an expert to create these sequences. In PolyWorks 2022, there is new functionality. It is regarding the use of the Renishaw PH20 ProPed and its 5-axis functionalities with PolyWorks. With PolyWorks 2022, we are bringing the benefits of our powerful CMM solution to PH20 systems. So, let us begin with a look at a PolyWorks 5-axis measurement sequence in action.
In this example, we have a CMM programmer and a CMM operator collaborating on the inspection of a machined pump housing. This template was created and uploaded by the programmer and is being downloaded by the operator. Thanks to DataLoop, it is easy to transfer a project from the programmer's office to the metrology lab. This project contains a 5-axis sequence to be used with our Renishaw PH20 head. The operator is about to measure a new piece, and we are going to take a closer look at the measurement process in action. I will be highlighting the new functionalities that will be explained in more detail as this workshop progresses. This sequence step defines the speed and acceleration values for the A and B axes of the PH20. As we see now, the first steps in any CNC CMM sequence are to probe the alignment features, in this case, our datums. Here we see the first use of a 5-axis movement within PolyWorks Inspector. This cylinder is being measured efficiently using 5-axis movements to minimize the time between measured points. Here we can see a tool change and a go-to position occurring simultaneously within a multi-axis go-to position group. This is yet another new 5-axis functionality offered within PolyWorks Inspector this year. Here we can see the optimal measurement of a plane, utilizing all 5 axes of the PH20 in the process. This part of the sequence is interesting. We see how well the sequence is utilizing the combination of 5-axis go-to positions and head touches to measure all those cylinders around the part. As you can see, as soon as the head is done measuring the cylinder, the 5-axis go-to position kicks in, allowing the head to be quickly ready to measure the next feature. Comparison points can now be measured using head touches while running a standard PolyWorks measurement sequence, just like other supported CMMs. The measurement sequence is now complete, and so is the report. This is the typical day-to-day process of a CMM operator. The measurement sequence can be easily repeated automatically to measure multiple pieces.
There we have it. We've just seen the day-to-day life of a CMM operator using PolyWorks. The operator quickly retrieves an inspection project prepared by someone else using DataLoop, and then runs the collision-free inspection on a CMM, measuring multiple pieces using the PH20 ProPed. This is a very efficient workflow. Many of you watching today probably use the PH20 already. The PH20 is popular for probing applications where high accuracy is required, while maintaining high measurement speeds. So I would say any industry producing complex parts with tight tolerances. In such a context, using PolyWorks will be an advantage because of how simple it is to prepare a measurement sequence for a complex part. It is not surprising that now inspection project preparation within PolyWorks should drop to below 1 hour. PolyWorks does this by leveraging the existing sequence creation technology. It is a simple two-phase approach. First, PolyWorks uses the smart assisted sequencing tools to quickly prepare a collision-free, three-axis sequence, and then the sequence is optimized for the five-axis functionalities of the PH20 ProPed. Let us see how to create the three-axis measurement sequence.
Here I have a piece template containing the same pump housing part we saw previously. All the required measurement objects are already created. I just need to create an optimal three-axis measurement sequence. I will be running the UCC server in offline mode. This is a requirement for offline simulation with the PH20. Also, I will be using the I++ plugin to connect to the CMM with PolyWorks. I will begin by connecting to my device. Now, I will open the sequence editor and start recording to automatically add the initial required steps into my sequence. Next, I will utilize a CMM pre-alignment to quickly pre-align the part to the device. The selection of my axis is already correct, so I will now simulate the measurement of the selected feature center point. Looking in the bottom right toolbar, I can see that collision detection is active. I can begin adding measurement objects to my sequence. I will be using the assisted sequence tool to efficiently add measurement objects to my sequence. I will select the alignment features in the tree view, then add them at the end of the sequence in an optimal order. This allows PolyWorks to order the selected features in a logical, efficient measurement path. Go-to points will also be generated to ensure collisions do not occur. With these features added, I will now execute my sequence. As explained at the start, I am connected to an offline simulation of the machine, so I do not need to be connected to the actual machine to prepare my project. All the measurements we see taking place now are being simulated. Now that my alignment features are measured, I can create a datum reference frame alignment to datums A, B, and C. With the final alignment in place, I can continue using the assisted sequencing tool to add the rest of the measurement objects to the sequence. The recommended workflow that I will be using allows the assisted sequencing tool to quickly build a complete sequence while letting me stay in control. First, I will select a group of features that will be measured using a specific tool orientation. Next, I will select an optimal tool orientation to measure these two features. It is important that we record this step so that the tool orientation change is saved in the sequence. With the Pick and Change tool orientation feature, I can pick the tool orientation directly from the CAD model. This intuitive tool allows me to select the orientation of the PH20 ProPed without worrying about complex A or B angles. Next, I will use the assisted sequence toolbar to lock the orientation of the tool to the current one I just picked from the CAD model. Now I can add the selected features to the end of the sequence. Remember, this still allows for optimization of the generated steps. Now I will execute my sequence. I will show you this workflow again with the next feature. First, I will select the cylinder in the 3D scene. Then, I will activate the assisted sequencing toolbar. I will then begin recording my sequence. Now, I can pick the tool orientation from the CAD model. And finally, I will add the cylinder to the end of my sequence. Now, I will execute my sequence. I will fast forward a bit as I continue measuring features with this workflow. To add circle 1 to the measurement sequence, I will select circle 1, activate the assisted sequence tool, and allow it to add tool orientation changes directly to the sequence as needed. Then, I will add it to the end of the sequence. I will now execute my sequence. The assisted sequencing tool is not just limited to features. I will show you by adding a handful of surface comparison points optimally at the end of my measurement sequence. I will use the same workflow that we saw at the beginning for features. Only this time I will select the comparison points. Activate the assisted sequencing tool, begin recording, pick my tool orientation from CAD, and lock the tool orientation to the active orientation. Now I can add my selected comparison points to the end of my sequence and execute it. Now the comparison points have been added to the end of the sequence along with the supporting go-to positions. Now I have a 3-axis collision-free measurement template. I will delete the measurements so I can have a clean template, and then I will upload it to the PolyWorks DataLoop server.
Now, more about PolyWorks Inspector's assisted sequencing. It is a smear functionality that adds objects in the optimal measurement order, while adding the go-to moves to avoid collisions with the part, the fixture, or other artifacts. It is at the heart of the CNC CMM sequence creation in PolyWorks since 2019. Assisted sequencing makes it easy and fast to prepare a collision-free sequence with the optimal measurement path. It is an extremely efficient way of preparing a sequence. And as you may have noticed at this point, there is nothing specific to PH20 heads. The 3-axis sequence preparation process is the same, no matter which hardware you use, which is why we say our workflow is universal. At this point, you would be ready to measure if you were using a traditional index head. But to benefit from the full 5-axis capabilities of the PH20, there is a short second phase. And this is where it gets interesting. So now we will see what is new with PolyWorks 2022. We are introducing a new toolbar that lets users easily optimize their 3-axis measurement sequence with 5-axis moves and head touch probing. We will now see these steps in action.
I will start by creating a new piece template from the 3-axis piece template I created in the previous video. To start the optimization, I will activate the I++ multi-axis utilities toolbar. This is where I will find the tools to unlock the full 5-axis measurement potential of the PH20 in PolyWorks Inspector. The first step is to insert head CNC parameters into the sequence. It is important to insert this early into the sequence as it defines the parameters to be used by the PH20 during head touch measurements. The first optimization tool allows me to insert multi-axis go-to position steps into the measurement sequence. This time-saving tool is used to optimize go-to positions and tool orientation changes into one fluid movement. I will select the orientation change and go-to position steps I wish to combine, then convert them with a single click. Note that when I select an optimization from the toolbar for the first time, I am prompted to disable collision detection. This is a requirement when using the multi-axis toolbar. Because I originally created this sequence with collision detection, I can be confident that there will not be any collisions. Now, the multi-axis go-to optimization is complete. Let me remind you of this fluid 5-axis movement with a flashback to the first video. The next optimization tool in the I++ multi-axis toolbar is the Configure Feature Head Touch Measurements tool. This tool will allow us to optimize our feature measurement sequence steps for 5-axis head touches with PH20. The optimization tool workflow is very simple and efficient. Select features of the same type that will be optimized. For now, I will just select Datum Cylinder B. Now, open the Configure Feature Head Touch Measurement tool. We can see the selected features listed in the Features selection. We also have an option to select other features as well. For now, I will use the original selection of Datum Cylinder B. Below this, we have 3 approach types available. I will select Keep Probe Head Along Axis. This is a specific method for internal circles, cylinders, and cones that will optimize the measurement path along the axis of the feature and use head touches from the center of the hole to acquire points. I will also select Orient to Hole Axis. This is an option that enables the tool to align precisely to the hole axis while approaching the feature. I will show you what this optimized measurement looks like in action. Now, I will optimize a plane for 5-axis measurements. Plane 1 has a cylindrical feature directly above it, so I will use the 3-axis method. This method allows for head touches to acquire measurement points while keeping a fixed tool angle during movements between them. The benefit here is maintaining the maximum clearance between the head and part while still using head touches to acquire measurement points. The next plane I will optimize is plane 2. This plane is open and clear of potential collisions, so I will use the 5-axis method. This method allows for head touches to acquire measurement points and the 5-axis movement between them, minimizing overall measurement time. This tool optimizes the measurement of comparison points. It allows configuring comparison points for head touch measurements. Just like we saw earlier with features, there is an option for 3-axis or 5-axis movement between each point. When measuring multiple consecutive comparison points, it is more efficient to group them into one sequence step. This is what this checkbox allows. This will decrease the overall measurement time of a group of comparison points. In this video, we can see the measurement of a group of comparison points using a 5-axis movement between each point. I will continue and complete the optimization of my sequence using these tools. Here, I will add another multi-axis go-to position. You can see here that I am selecting multiple cylinders and optimizing the measurement of them all at once. In addition to my 3-axis measurement template, I also now have a complete 5-axis measurement template ready to maximize the efficiency of PolyWorks Inspector coupled with the PH20. I will upload my project to the PolyWorks DataLoop server, and it will be ready for immediate download and use by the CMM operator.
We've just seen how easy it is to optimize a CMM measurement sequence for a PH20 ProPed. It is simple and straightforward. By using the new I++ multi-axis utilities toolbar, we can firstly create 5-axis movements by combining tool orientation and go-to steps, and quickly configure objects for head touch measurements. As you have seen throughout this workshop, we have gone through the whole measurement sequence creation process, demonstrating all the steps. A complete measurement sequence for a part of medium complexity can definitely be prepared in less than an hour with PolyWorks. Our main goal today was to show that our CMM solution now fully supports the Renishaw PH20 probing heads for 5-axis part inspection. Now, thanks to PolyWorks, your PH20 measurement sequences are quick to prepare and easy to understand. You benefit from universal projects that can be used on any CMM if needed. And don't forget that you can easily share projects with your colleagues or suppliers thanks to DataLoop, our data management solution. Overall, these tools make your metrology process as simple and efficient as it can be. Now, thank you for your attention during this second workshop. Stay tuned for the next workshop entitled Improve Measurement Operator Performance by deploying mixed reality technology using the Microsoft HoloLens and PolyWorks AR 2022. Mixed reality headsets are powerful and helpful tools currently used in many industries. Our complete mixed reality solution for probing applications allows us to overlay information on top of physical parts you are measuring, and lets operators interact by way of virtual toolbars and a variety of gestures. We propose a new working paradigm that solves current problems and enriches the operator's environment. Now, you no longer need to look at or return to the computer or even touch your keyboard or mouse during an inspection. Of course, seeing inspection results on you or the real part certainly can help pinpoint and troubleshoot the issues. But the unmatched guidance capabilities of mixed reality are what we believe will bring the highest value to our customers. As soon as Microsoft announced the first version of the HoloLens in 2015, Innovametric pre-ordered some devices, but their real commitment started in 2017, and since then they have released 4 major versions of PolyWorks AR. Innovametric started their exploration of this technology by overlaying colour maps onto parts, and then, wanting to explore all kinds of scenarios, they built a macro toolbox allowing users to customise workflows with mixed reality. Seeing the potential for guidance, Innovametric started interacting with portable devices by supporting the build inspect mode, and they went on to support complete measurement workflows for operators using manual gauges. While those earlier versions targeted more specialised applications, in 2022 we are now going mainstream by fully guiding operators when probing. As you will see in the following videos, holograms offer guidance to assist the operators in measuring the right object with the right tool. But the holograms offer retro action as well to help operators validate their measurements and results in real time. All this without the need to look at or go back to the computer screen. So, are you ready to see it in action? Let's have a look.
To start this example, an inspector project has been prepared that has one piece measured. Now we will put on the Microsoft HoloLens 2 glasses and get ready to inspect the piece. From the HoloLens menu, we will launch the PolyWorks AR application. We are then prompted to select which project we would like to connect to. At this point, the HoloLens is downloading information from my computer in order to guide me with holograms. PolyWorks AR lets us know that we can automatically overlay the hologram of the CAD model onto the physical piece using a position stored in a QR code. We will come back later to show you how to store a position in a QR code. For now, we will scan the QR code next to the fixture to define the position of the CAD's hologram. Now, you may notice certain gaps in between the real world and the holograms, but that is just due to the recording process. The display is much better when looking through the glasses. We are now ready to play the inspection to run through the measurement sequence. The first step is a surface point alignment. Instantly, we see orange arrows to guide us to the first measurement area. With PolyWorks AR, it is incredibly easy to know where to probe the next point without ever having to look back at the computer. Let us now fast forward for the remaining 4 points. With the surface point alignment now done, we are guided to the first feature that needs measuring. PolyWorks AR displays the instructions during the measurement process. The object name is displayed alongside the measurement steps, such as local constraining planes and any guiding instructions added when setting up a project. On top of that, we get instant feedback on the point acquisition, which is displayed as white holographic squares directly on the piece in front of us. For the slot feature, we need to probe 2 arcs, and looking at the information in front of us, it is clear where we are in the probing process and what we should be doing next. With this first feature probed, we are again guided to the next area to measure. This allows us to cycle through all the inspection steps directly from the HoloLens and benefit from next level feedback, again, without ever having to look at a computer screen. At any time, we can take a step back and look for the next feature to measure, which is clearly indicated at the end of the arrow and with a blue contour. The HoloLens continually tracks our movement in the room, so even though we are kneeling on the floor, it always knows our position relative to the piece and guides us correctly through the measurement process. Sometimes, comparison points can be hard to probe, as you need to be within a certain radial tolerance. PolyWorks AR makes the task a lot easier. Simply place the orange probe within the target area, and you'll be sure to measure it at the right place. Now, what about making sure that you have good probing coverage for certain objects, like a plane or a surface, for example? Well, here again, superimposed probe points and the blue contour outline provide the feedback needed to make sure that good probing coverage of the surface has been obtained. And if some of the points are mistakenly taken, we can right away eliminate them and see the result on the hologram. Here we leverage the enhanced guidance of PolyWorks AR to help obtain repeatable measurements with the help of guided point acquisition. This allows us to see exactly the location of spheres, limiting the acquisition area, and it controls the location and the number of points we need to probe for this feature. We know when the probe is within the acquisition radius as the point turns green, and intuitively, we understand which of the points are left to probe, as the already probed ones disappear once they have been measured. At the end of the inspection, annotations are displayed to allow me to review results instantaneously and overlaid at the right location on the part. We can freely walk around the part and close in to look at the annotations. With PolyWorks AR, we get ergonomic operator guidance and enhanced live visual feedback for all the probing applications.
There we have it. A hologram's great. They move with the operator's position, provide clear guidance and feedback, and are always perfectly placed. At one point, you forget their novelty and they become useful tools that are always within reach and reactive to the situation. Not having to look at the screen is a major benefit, but not having to walk back to the computer screen is another key advantage of using mixed reality. With gestures, you can launch actions on the spot without having to go back to the computer. This is especially useful when working on large pieces, which are often measured with laser trackers. Also, since the measurements are mainly acquired with reflectors, which don't have buttons, access to virtual buttons is a real game changer. Now, we'll head back to the video to see the advantages of using PolyWorks AR with laser trackers.
A tracker is being used that would usually require multiple trips back and forth to the computer. So let us see this in action. We will start by scanning a QR code to retrieve the hologram position and begin a new piece inspection directly from the headset. Going through the surface point alignment, we can just follow the orange arrows from one measurement step to the next. Let's fast forward the surface point alignment. Knowing the next point to measure really makes the tracker measurement effortless on such a large part. After measuring the surface point alignment, we can follow the vivid guidance provided by PolyWorks AR to run through the entire inspection and focus our attention on what is right in front of us. We are measuring cylinder 1 with a fixed number of points, 8 to be exact. As the points are being acquired, they immediately appear in the field of view. The next measurement is the backplane. Its contours are highlighted with a blue line and its points are displayed as they are taken. The only thing missing is to compensate the point, as indicated in the visual display. Unfortunately, we have lost the laser beam since the laser tracker head did not follow us to the position. No worry, we can use the Come to Me feature to quickly catch the beam and continue the inspection. Now we will need a pin nest, like the one here, to measure this circle. We can change to tools directly from PolyWorks AR's interface without having to run back to the computer. We are not sure whether those first 3 points were in contact with the surface. Therefore, they will not have been acquired correctly. We will just delete them and restart measuring the hole. The final feature to measure is the biggest one. We need to probe the complete boat surface, starting at the front and going all the way to the back, whilst displaying all the points being acquired. Let's fast forward. PolyWorks AR allows us to control the complete tracker measurement process without having to go back to the computer for point acquisition, tool change, and other functionalities. Now, all of our attention is on the immediate environment. That is the real game changer. This tool is going to accelerate and simplify any data analysis processes. We can now review results immediately after taking measurements while looking at the part. So we can now spend less time tied to the computer and more time building boats.
We can now definitely see how using a mixed reality device can be useful when inspecting large parts away from the computer. And like we saw in the video, having the tools and the results you need at your fingertips can easily turn a 2-person tracker job into a 1-person job. Now that we have seen all the benefits, this seems too good to be true. There is no need to prepare anything special, as all PolyWorks inspection projects are already compatible with PolyWorks AR. Rather, it is PolyWorks AR that will adapt to the content of the project. Really, the only requirements when using this tool are to install the app, master the hand gestures, and learn how to position the holograms on the part when using it. The process is, however, not complete. You will all see in the next video how to install the app and then how to locate the holograms on the physical part. Finally, we will see how some PolyWorks inspector parameters impact the user experience when using mixed reality.
To install the app on the HoloLens, simply browse to the download page on the Technical Support Zone. Put on the HoloLens and virtually click on the QR code, which will open the download page of PolyWorks AR on the Microsoft Store. Afterward, we have to activate the plugin from PolyWorks Workspace Manager options. With a Wi-Fi connection between the HoloLens and computer, we can connect to the project. As soon as the project connection is completed, we begin the first manual alignment where we can grab the hologram and move it into the room. The menu follows the operator when you manipulate the part. It then disappears and then reappears right away. We can adjust the hologram using hand gestures. And when we are close enough to the part position, we can activate the auto-locate function to refine the hologram's position, just like a best fit would do. To adjust the hologram's alignment even further, we are going to start the fine-tune alignment. When entering this function, you see a gizmo that allows translating and rotating the holograms along the three main axes. It is possible to change the gizmo's position and angle to better your needs, as well as define the sensibility of your sliders. We can orientate the gizmo with its axes parallel or normal to the part. This helps us when moving the part around. When we are satisfied with the hologram's position, we can place a QR code next to the part and save this position for further use. This QR code must remain fixed to the part or fixture gauge. As we have seen in the first two videos, this can be quite useful if we are using a fixture for multi-piece inspection. Another way to refine the hologram's position is to use a tool called a pin. We are using manual gestures to bring the holograms into position. Once a portion of the hologram is in position, we can pin it to stop it from moving. Adding a second pin helps us to finalize the hologram's position. Notice the gap in between the scan and the hologram. This is caused by the recording process, but at the end, the hologram is properly aligned to the physical piece. When we are satisfied with this hologram position, the QR code can be updated. The HoloLens setup has now been completed. It is now time to start preparing the inspector project for the shop floor team. First, features and controls will be defined just like you would do in a standard PolyWorks project. For most of the guidance, you don't have to do anything to be able to use PolyWorks AR, since my inspector project is already compatible. The orange arrows, blue contours of geometries, and the measurement sequence are all handled by the application. Since we would like to show you all the possible options, let's go a bit deeper into properties that will affect what you see in your HoloLens. For example, adding the property for guided points and defining the guiding sphere, radius, and position. And even add guiding messages. The only missing portion to complete the inspector project is my metrology device. Let's align this measurement device using a surface point alignment and leverage once again the powerful hologram guidance to acquire data at the right location. This completes the project, which is now ready for the shop floor team. We are providing them a project that is ready to use by scanning a QR code and following the compelling hologram instruction, like we saw in the first part of this workshop.
We have just seen not only the capabilities of PolyWorks AR, but also how to use it, from the installation to positioning the holograms. This is a brand new experience for operators inspecting parts on the shop floor, offering them a tailor-made solution. Today, we saw how holograms can guide operators to the correct object while providing real-time feedback during the inspection, how laser tracker inspection can benefit from mixed reality, and finally, it is easy to implement. It is all there in PolyWorks 2022. Just get a HoloLens 2 device and mixed reality could become your reality for tomorrow's inspections. Now, on my side, I simply hope that this workshop has opened your eyes to what mixed reality can bring to metrology. As you saw, probing can be much more efficient by having unmatched guidance and easy access to tools directly next to the part, without having to look at or even touch the computer. Yes, this might look futuristic, but the future is now, and our solution is ready. If you have a chance to try it, you will see for yourselves. If you've enjoyed today, then don't worry, this is not the end. In fact, we have plenty more PolyWorks 2022 inspired content lined up just for you. Register now for our first follow-on webinar using the link in the chat. We would also love to hear your thoughts from today, so much so that we're offering you a coffee on us for feedback. You'll shortly receive an email with a link to the survey. Simply complete the form and in return, we will send over a Costa coffee voucher just for you guys. But for now, this was the PolyWorks Conference Live 2022. Thanks for joining us on our journey to discovering what's next in 3D metrology. Thank you and goodbye.